guys, this is Professor Janacek, and I want to go over an example where we take the limit at infinity by using the squeeze theorem. So a combination of a couple of ideas here. All right, so let's take the limit as x approaches infinity of 5 plus sine of x over the square root of x. All right, first thing I want you to notice is that as x approaches infinity, what happens to the square root of x? Well, x is definitely getting very large, but the square root of x, it's not as large as x, but it's still getting fairly large. And with a few examples of taking the square roots of values, you'll eventually see that this is still getting big. It's not slowing down, but it doesn't go to infinity quite as quickly as x, but it's still going to infinity. All right. Another thing to note is that, remember, as x is getting large, the square root of x, that does remain positive. That's going to be important to us here in a bit. It is going to stay as a positive value. All right, well, what about 1 over the square root of x? What happens if the square root of x is now in the denominator? Well, if the square root of x is getting large, then 1 over the square root of x is getting small. So remember, as something gets really large, its reciprocal ends up getting really small. So 1 over the square root of x is going to 0. All right, now let's see. Looking again at this argument, I'm not too concerned with the 5. We've already kind of talked about what's happening with the square root in the denominator. Let's talk about the sign. That's where I kind of want to start this. So, looking at the sine of x, we know that the sine function is bounded between -1 and 1. So we can write this way, that -1 is less than or equal to the sine of x, which is less than 1. Now, since I know the square root of x is a positive value, then I can write that -1 over the square root of x is less than or equal to the sine of x over the square root of x, which is less than or equal to +1 over the square root of x. Again, this only works because the square root of x remains positive out here. All right, but now, oh dear, let's take a look at the limit as x approaches infinity. Again, that's the limit I'm looking for at the top of the page, of the left-hand value, -1 over the square root of x. So notice I'm just taking the limit of this left-hand piece. Well, whether it's positive or negative, we know that this is going to 0. That's what we got up here. That's that idea there. Okay. And what about the limit as x approaches infinity of +1 over the square root of x? So now I'm looking just at the right-hand piece. But again, we saw that up here. That is also going to 0. So this tells me that the stuff in the middle, now, here's where the squeeze theorem comes in. I can squeeze this in between those other two functions. So we now have that the limit, the limit as x goes to infinity of sine of x over the square root of x, that is also equal to 0. So this tells me that the limit that I'm looking at as x goes to infinity of 5 plus sine of x over the square root of x. Well, first, using properties of limits, we know that this is equal to the limit as x approaches infinity of 5 plus the limit as x approaches infinity of the sine of x over the square root of x. And we know that the limit as x approaches infinity is 5, regardless of what x is. Our function is a constant, remains at 5. And we just learned that the limit as x approaches infinity of sine x over square root of x, that's equal to 0. So that gives me this last little bit. That's all 0. Boop, boop. Therefore, the limit as x approaches infinity of 5 plus the sine of x over the square root of x is equal to 5 plus 0, or simply 5. And there you go. Enjoy.